So the simplest aspect of naming organic molecules is the substituents that are indicated by the prefix only. In the handout that I got you sent to be via email, it's labeled in this as Group C, substituents indicated by prefix only. It's on page 2, it looks like. Yep, page 2. So we have alkyl substituents, and we worry about halogens. An alkyl, that could be any R group that have a shorter chain length than the main chain. And then the halogens, of course, that's going to be your fluorine, chlorine, bromine, and iodine. The information that I sent you also lists an alkoxy group. But alkoxies they're not in the same priority. I don't even really understand why they listed that there, because they even say that in the instructions. Some miscellaneous substituents that they list are nitro, vinyl, allyl, and phenyl. Once again, those are some exceptional things. I don't know why it's listed here, but I didn't come up with this. This is like the official rendition of the IUPAC naming that I was able to find. So maybe it had something specific with whoever actually named whoever created that document. So I wouldn't even worry about alkoxies here. We're just going to talk about alkyl. Oh, that was supposed to be L. I thought it was a parentheses. And halogens. So if we've got a organic molecule here, and I'm going to draw all of this in the what I call the skeletal structure, or line angle, I think is what the other book calls it, because it's just quicker. So if we take a regular organic chain here, and we're going to say 1, 2, 3, 4, 5, 6. So here we've got 6 carbons. And on the second one, we're going to throw a bromine on it. And on this third one here, we'll put a chlorine. And then maybe we'll put another chlorine here. By using the naming conventions, and we have talked this through in class multiple times, I just want to make sure that we're reviewing this so we know. We would count out the carbons in the longest chain. Find the longest chain. Here it's 6. 1, 2, 3, 4, 5, and 6. We want to number the chain because we could number it the other direction. 1, 2, 3, 4, 5, and 6. But if we number it from right to left in this illustration, we actually wind up with the lowest number for a substituent will be the third carbon, but we really want the lowest number to be on the we want the lowest number substituent possible, which will be on the second carbon here. So in naming this, we have 6 carbons, so that's going to be hexane. It's all single bonded, so it's just hexane. We also have some substituents. We have 2 chlorines, and we have 1 bromine. So to name this, we'd see bromine is on carbon 2, so this would be, well, I should have done this in a different line. Hold on. Let me move that around. So with bromine, that would be 2 bromo, because it's on the second carbon. And then we would have 3,4 dichloro, and then hexane at the end of it. It can get way more complicated than that. You can have as many substituents, halogenated substituents, as you have hydrogens on a alkane chain. And it just can happen that way. Now, we also talked about previously if we have short chains along the side of it. So let's draw another hexane here. Well, let me do that in blue. 1, 2, 3, 4, 5, 6. And an alkyl group on this would be like if we had a methyl group there, and we could even have an ethyl group here. And then we've got another type of ethyl. This is a propyl group here. So let's make sure. You know what? I may have actually made a longer chain than 6. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No, 6 is my longest chain. So in this step, I would need to look at it and say, okay, which direction would I count my chain from? Well, if I count from my initial chain you saw me draw, 1, 2, 3, 4, 5, and 6. That would be our carbons. Now, if we counted it in another direction, if we counted from here, 1, 2, 3, 4, 5, 6, that'd still be the longest chain. If we started up here, 1, 2, 3, 4, 5, 6, that would be a 6 chain also. So any way we look at it, it's going to be a it's going to be a 6 membered chain for our organic or base chain there. So let's go back here and let's name these. So at this point we have this is actually a CH3 group here. So that would be a methyl. So we know this is a methyl. This is methyl ethyl, so that's ethyl. And you see here we have 3 carbons, 1, 2, and 3. So this would be a propyl. But the bond is not on the very first in the propane chain, it's on the second. So that's going to be secondary propyl. It's on the second carbon instead. The common name for that is actually isopropyl. All right, when it's on the second of the propyl substituent. So in this case, we need to name these in alphabetical order and according to the number on their main chain that they branch off of. So we'd start out with ethyl. So this would be 3 ethyl. All right, so we took care of ethyl. LMNOP. I had to sing the song every time. But here we have iso. So this would be isopropyl. So this would be 4 isopropyl. And then, so that took care of those 2 substituents. And then our last substituent alphabetically is methyl. And it'll be 2 methyl. And then the longest chain here would be hexane. And that's how you would name that one. Now I'm going to do another one that is a combination of them, so we can see how that would work too. So let's get a 1, 2, 3, 4, 5, 6, 7, 8. That way I know I've got the longest chain there. And in this case, let's have a chlorine here, and let's also have a ethyl group on it also. Maybe that was poorly drawn. Maybe I should have drawn it the other direction. Anyways, you get the idea. And then let's throw a bromine over here, just for good measure. So if the structure was built like this, and we start numbering it, we would see that if we numbered from left to right, we would get 1, 2, 3, 4, 5, 6, 7, 8 carbons in our chain. But we want our substituent to be numbered so that the lowest number possible is given to our first substituents, for our substituents. So we would actually number this one in the opposite direction, 1, 2, because then that would put our bromine on 2. If we go the other direction, the chlorine winds up on 3, and so does the ethyl. So this would actually be the correct direction. I'm going to number it underneath. 5, 6, 7, 8. All right, so we've got 8, so we know it's going to end in octane. Now let's start naming our substituents. We're going to name them alphabetically. Bromo comes first, and then chloro, and then ethyl. So here we would say this would be 2 bromo, and I did not mean to capitalize that, but that's just habit. 6 chloro, 6 ethyl, octane. So the name is a mouthful there, that's for sure. All right, so that's what is called in the handout the Group C substituents, and that's kind of how that works. I mean, we can make these way, way more complicated, but, it's not really necessary at this point. We're just naming them. Okay, I'm going to come back with some of the Group B stuff.